Okay, welcome to the Vision Break. In this video, I will show you how to train custom Mask-RCNN instance segmentation models with PyTorch. You can read this article. I will share the link in description and comment section, or watch the video. It's up to you. Everything is same. Let me quickly show you what are we going to do. First, we will find the dataset. After that, we will check if GPU is available in our environment. Then we will create custom PyTorch dataset class. After that, we will create two different sets. One is for train and other for validation. Then we will see some example images from our datasets. After that, we will load a pre-trained Mask-RCNN model. I will use ResNet 50 as a backbone. Then we will change some parameters like learning rate. Then we will train our model, like there's simple for loop. You can see the training process from this image. It is a little bit low quality, but I will train it so you will see it. Then we will load our trained model and make some predictions like this. So we will test our model in the end. Yes, I think we can start. Okay, first step is dataset. Okay, I'm not gonna create a dataset from scratch. I will use this dataset. I found it from GitHub. The name of the dataset is car parts dataset. You can see some examples, masks and images. There are some details like instance per category. You can look at it. There's some documentation as well. Let's check it. Yeah, it seems good. Yeah, you can click this link and check this dataset. I already downloaded and unzip it to my base folder here. You can see car parts dataset. There's two more subfolder, train and valid. So we can inspect train folder. You can see there are a bunch of images. These are training images. Let me show you a few of them. You see. And there is one JSON file, and this JSON file contains information about this training image. You see like bounding box coordinates, segmentation coordinates, so mask coordinates, and other things like, let me show you, ID, class name. There must be image names. Yes, you see image name. Yeah, information like this. By the way, this is same for validation folder, like same format, one JSON and validation image. Okay, I think I can close this. Okay, let's move on. Yes, now we will set up our environment. I have a GPU supported PyTorch environment. If you don't have GPU supported PyTorch environment, you can use servers like Kaggle or Google Colab. You see here. They offer free GPU. You just need to upload your dataset, create a notebook, then activate your GPU. So by doing like this, you can train your models. And I personally recommend to you using Kaggle. It offers like 30 hours weekly usage limit. It is more than enough. But Google Colab has some restrictions. But of course, you can try both of them and choose whatever best is for you. Okay, you can see my environment here. Let me execute this cell. It might take a little bit time to, yes, 5 seconds. So it says device type CUDA. This means that GPU is available on our environment. So we are good to go. Okay, we already did that step. Create custom PyTorch dataset class. Okay. Let me show you. You can name this class whatever you want. It doesn't matter. You can see here constructor. And I added comment lines. You can read it, but I will explain you too quickly. Here there's like directories. This means that our dataset will be in Cocoa annotations, image IDs, and transforms. Transforms are basically like normalizing our image, maybe adding some augmentation. You can define this, like for example functions like this. You know, here we are converting pill image to PyTorch tensor, so it is normalizing automatically. But you can add, of course, different things like augmentation. So this len method returns the total number of images, and this get item returns two things. One is image, other is target. This is normalized image, not original. And target contains information like box, labels, masks, image ID. So all the necessary information for training. Yeah, you can read those. I think it's clear. Okay, let me check other step. Create, train, and validation sets. Okay. So we will create two different sets. One is for train and other is for validation. You see there are paths, car parts dataset slash train. It's same as here. And you can see there is one JSON file. It's exactly this file. We already checked this. Let me close this. This is same for validation, by the way. You only change this train to valid here. And here we are passing this get transform. We already talked about it. Where was it? Yes, here. You see. You can change this transform function. You can add augmentation and other things. Here we are just normalizing and transform it to the PyTorch tensor. Let me execute this. Oh, I forgot to execute this line, this cell, not line. Okay. No problem, we can move on. What is the other step? Oh, we have one additional step here. I separated it here. You see this is different cell. Here we are loading our dataset with data loaders. By using data loaders, like training will be done on batch, not on full training set. So here my batch size is 2. You probably see batch size like 8, 16, 32. They are totally okay. I'm just set this to 2 because of my GPU's memory. I don't have a powerful GPU, so I set it to 2 and 1. But if you have more powerful GPU, I recommend you to put here like 8, 16, 32. So no problem. Here we have class names. First is background and other ones. Let me check. For example, back right light, wheel, left mirror. Okay. Yeah, display sample image from the data loader objects. So we will basically display some random examples from train set. You see here. This step is not that important, but I think it's always good practice to see some random image. Class names is not defined. Okay, I always forget some cell. Yeah, it's always good practice to see some example image like this. You see labels and masks. It's a little bit complex, but it's okay, I think. You see one more example. Back right door, for example. You see the label, you see the mask. For example, mirror. Okay, we can continue. Load a pre-trained Mask-RCNN model. Okay, let me explain this cell. So here we are loading our backbone of our model, ResNet 50. We are setting this pre-trained to true. This means that this backbone is already trained on a big dataset like Coco, so we will use that. Here, this is the number of classes. Here we are finding total length of training set labels. It's same for validation, and +1 is for background. Yeah, by the way, we imported the important things here, like prediction heads, and we can continue. Yes, what is that? Yeah, we have two separate prediction heads. First one is for classification and bounding box regression head. Here you can see fast RCNN predictor. And second one is for mask prediction head. You see here. And we have some, for example, number of input features to the classification layer, this variable, and we are passing it to here. And as an output, we have number of classes. We just define it here. And it's same for mask prediction head. There is one additional thing, and that is number of hidden layers. You see here, again, we have number of classes as output. Yeah, that's it, I think. And we are moving the model to the GPU for faster training. Let me execute this. Okay, nice. Yeah, by the way, you can see transforms here. As I said before, it normalize and it resize. And you can see full model from here. There's like different layers, convolution, ReLU activation function, and there must be max pool as well. Let me find. Where are you? Maybe in the end. Yeah, I couldn't find, but there has to be in somewhere. Yeah, it is not that important. Yeah, here, for example. There's different parameters like kernel size, stride, padding. Okay, that's it, I think, for this step. Okay, adjusting training parameters. You see we have few parameters. Actually, these are models learnable, not learnable, trainable parameters. So these parameters will change during training for model to perform better. You see here. And we have like, I choose stochastic gradient descent as optimizer. You see there's learning rate, momentum, weight decay. You can change this value depending on your result. For example, you can decrease learning rate and increase epoch size, so your training might be more stable. Yeah, these results they are not like magical values, you know. You always can change different combinations. But I set this like this for now. Okay. So the other step is clone the PyTorch vision repository and copy the detection utilities. Okay, I already did that. Go to your terminal, clone this repository. After that, here you can see vision repository. Go to reference and detection. You see there's like 5 important files. These 5. Copy it from here and paste it to here. You can see I have 5 of them. Coco eval, utils, engine, transforms, and utils. These 5 files will be used in training. You'll see now. Okay, we did this step as well. Okay, now we will train our model. Let me do like this. Okay, I set the number of epochs to 10. You can increase or decrease this value. There's simple for loop. So train one epoch, evaluate, and in the end of every epoch, I'm saving our model to models directory. You see here. By the way, I already trained the model because I don't want to wait. It takes really long time, so I already trained it, and I'll show you now. So you see there's 10 model for 10 different epochs. You can test every model here, but I will use the, of course, last model. Now I'll show you training process. You can see it start from epoch 1 and there are loss values. For example, loss mask. You can see how long does it takes, for example, for testing. Yeah, there are like bunch of values. You see, for example, epoch number 3, loss is decreasing. Nice. Yeah, it's like this. You see there's 10 model. Okay, what is the other step? I think it's the last step. Yes, load trained model and make prediction on images. Okay, nice. Let me go here. Okay, now we will load some model. Not some model, we will load our last model from here. Copy path like this. Okay, you see epoch 10. Then we will load our image here. Apply transforms. And then we will make prediction. So I will choose some image from validation set. This is not a good practice, of course, but I don't have a separate testing set, so I will just use image from here. But you can download an image from internet and test on it, or download a test set. I will do like this quickly. I know this is not a good practice, but this is not the purpose of this video. I just want to show you how to train a model. Yeah, you see we have this image and we have predictions. You can see the mask of a wheel and label. You can see confidence values. It seems pretty good. For example, front left light. You can see the mask. By the way, you can change these colors. There must be some, yeah, for example, this means colored mask. There's alpha value. Let me increase this. Yeah, you see, they are more intense. And we can test it in another image. Yeah, this one seems okay. Copy paths. Okay. But where is alpha? Yes, I will decrease this after this. Yeah, you see wheel again. For example, front right door is true as well. There's one more wheel. Okay, I think it is enough for now. Okay, thanks for watching my video. See you soon.